Architecture 497X, and we're going over the first processing exercise. And what you need to be doing is working with whatever your script is for your processing creature, and we're moving it from the way we've written it currently, and you can see my script up here now. And we're trying to figure out how to make this creature center no matter what size we give sort of the digital paper to draw the sketch on. And so if you look here, you can see I've started my code with that size command, and that's setting up my paper size, and we've got it set at 200 pixels by 200 pixels. And then I just go ahead and set the rest of all the functions just based on their normal standard forms. And so the rectangles are drawn from the corner. The lines, of course, are point to point. And then this is sort of the corner version of the ellipse as well. And so everything is sort of basing off a logic of the mathematics, starting from that upper left corner and thinking about those different shapes in relationship then to width and height based on that corner location. So if we think about that logic and we think about what it's going to take to basically create a self-centering sketch, there is a way to use these standard forms of drawing and figure that out, but it makes my brain hurt to think about it. So I'm actually going to be switching a bunch of this stuff. So first of all, I know you guys have seen my little creature before, but just to show you that the script actually draws him, there you go. And he's a little bit more simple than those final versions, and that's just because the next exercises get into some of those other things. And so this is just a black and white sketch. You guys, some of you have picked colors already. There's no problem whatsoever. You can just keep those the way they are. And the only exercise we're really doing here is about the geometry of the relationship of the shapes versus the size of the paper. And what we want to do is keep that little creature centered no matter what size we make the paper. So first, let's just make sure we understand that, in fact, it isn't centered now. And so if I change that paper size from 200 to 200 to 400 to 400, and I stop the sketch and run it again, our little guy is going to be up in the corner. And that should be what you thought was going to happen. And so now what we want to do is get that little fella to be in the center. So I'm going to do a couple of things just to begin with. And what I'm going to do is actually change the way I'm drawing things. Because like I said, I think it helps me if I'm thinking about centering things to actually draw them from the center. So I'm going to go to my rec mode, and I'm going to change that to, center. And I'm going to do the same thing with ellipse. And so you should be looking at those commands and understanding that that's going to change the mode of drawing. So if I try to execute this drawing now, I'm going to get something that's really wonky. And so we'll go ahead and do that just to show you. Oops. What's that little error about? I've got some little thing wrong there. Oh, I forgot the word mode. You probably got that before I did. If you did, good job. Okay, let's hit stop on that. And so what I just did there, you saw I had an error message pop up, and so I just read that error message and figured out sort of what was going wrong. It told me that my problem was in that ellipse line, and so I had to look at that and figure out what I had done wrong. And there we go. Things are wonky as we sort of thought they would be. So now the question becomes, how do I look at the mathematics that I'm dealing with in all of this and basically fix that? Well, one of the problems you can see right away is that I haven't commented this at all. So I have no idea what things are. One way to check. I have a suspicion that those first 5 lines of code are the body and those 4 little legs. And so one thing I can do is just sort of put that on the clipboard, the rest of that code, and run it like this, and then I'll be able to see that indeed that is what I think it is. And so that means if I paste back the code that I got rid of, these ellipses are all actually dealing with the head, and this down here is actually the face. And so working off of that, then I need to start thinking about the logic of what's going on here. So if you remember before the way these things were being drawn, rectangle for instance before, this was the corner, and this was the width, and this was the height. Now this is the center point. and this is still width and height. So we want to change that. We want now the center point to basically be, in this case, we're going to try to make this, remember before I had it centered on the nose. Let's center it on the rectangle and see what we can do there. So there basically are hidden variables in processing. And what those hidden variables are basically these two functions right here. And so you have width and height, basically. So you can imagine if you were typing this, if you were coding this function under size, size would actually be the call. You're calling the function size and you're slipping it two parameters, two variables, and those variable names are width and height. And so because I know that about processing, and because you guys now know it because you've read it, we can actually put width and height in here in the center point. And so we can say width divided by 2, because we want that to be the center of the drawing now. And so we get rid of these 105s, and now we say height divided by 2. And we know that we're hitting actual keywords because notice those terms went red. And so let's see what we do. And so what we should expect to see is this rectangle should move to the center of the drawing. Now nothing else is justified like that, so it'll look really funny. But look, it showed up just like we thought. So now what we have to do is basically recompute this area of the drawing so that it responds like this does. And so some parts of this are easier than others, and I'm just wanting to be conscious of how long I'm making this video. But that is basically the mode that you're going to be working with. And so let's think about the head now, right? Because the head, this is where you see sort of the difficult math, quote unquote difficult math. It's not really difficult, it's just a lot of attention to detail. So we need to figure out which one of these ellipses, because again, remember, I haven't been a good coder, and so none of this is commented, but I am pretty sure that this is my head ellipse, and I'm pretty sure of that because it's the bigger, notice 55 by 70. I'm going to just cut that code out and move it up here. And as long as I'm starting to organize things, why don't I be a good coder and comment that and say it's my head so I know. And so I should say this, I can follow through here, and this is my body and legs. Yeah, so you notice I just use those two slashes, and then that basically makes it so that the computer doesn't read those as code and allows me just to comment those out so I can use those notes to myself that way. So I think all I'm going to have time to do on this is, and you'll get the pattern here, is really think through this. We're going to basically be looking, I like the size of my ellipse, so I'm going to keep the 55 and 70 the same, but now the question is, what is the center of my ellipse, right? Well, I want the center to be, because it's my head, so I want it to be over the body, right? So that part's easy. So the center point of the ellipse is going to be width divided by 2 still. And then the question is, what is the height going to be, right? Well, I want to start with that center point. The height is, the center point of my rectangle is, right there. So I want to keep that. That divided by 2. Now the question is, how far up should I go to place this ellipse? And let's look at that rectangle originally. So we know that rectangle is 20 pixels by 50 pixels. So to get to the top of the rectangle, how do I have to change that center number? What do I have to do to the center number to get to the top? This point right here where the tip of my arrow is. Okay, you should be thinking something like, well, you need to add 25 to it. But here's the trick. Remember, in computation, this is 0, and numbers grow this way, and numbers grow that way. So when I want to move up 25 points, I'm actually subtracting 25 points. Yeah, so that's confusing, but that is the process. And so as long as you remember how the graph works, if we imagine this as graph paper, as long as you remember that, you should be able to figure all this stuff out. Now, the problem is, when I move this to 25, I'm going to go ahead and play it for you, and you should know that I'm still not going to get it right. And let's see if you can predict exactly why I'm going to get it wrong. So what do you think is going to happen? Figure it out. Is that what you thought? Hopefully what you imagined was that this ellipse was going to still overlap the body a whole bunch. And the reason for that is If you look at my code, I've moved the center up to the top of the rectangle, but we don't want the center. We want the bottom of the ellipse at the top of the rectangle. So again, now we need to look at the total height of the ellipse, and you see it's 70. So what I want to do is move that up an additional 35. So I don't want to subtract 25 here. I want to subtract 25 plus 35. And so you do a quick little math in your head, a little bit of arithmetic, and you should come up with that as 60. And so let's try that now. There you go. Now it's just touching. Okay? So that is basically the process. Now, if you went ahead and read further into the reading, you know that there is an alternative means of doing this, right? And that is a way of getting rid of the width divided by 2, height divided by 2. And that is a perfectly okay way to do this as well. I am accepting either one, either the more primitive version, which is what I'm sort of coding through here, or the more complex version using that cent_x, cent_y variable. So you just basically do that process and you work through the entire drawing. The lines are difficult, I'm not going to lie to you. Those sort of require the most amount of math, but there is repetition in them as well. So that should help you. Once you get one of them right, you should be able to figure the others out pretty well. Okay, well, good luck to you, and that's the first lesson.